بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. This is the first major of term 231 for linear algebra math 223. Let us have a look to the exam and solve it together. First question, we have given two matrices and calculate the determinants of each one of them. So the determinant of the matrix A, if you look to the matrix A, it's an upper triangular matrix. All the numbers below the main diagonal are zeros. For such matrices, the determinant is just the product of the numbers on the main diagonal. So 2 times 1 times -4, and that's -8. Also, if you try to solve it by cofactor expansion, you can expand using along the first column. So it would be 2 times this one, this determinant, which is again -4. So you can see easily that this formula is accurate. The determinant of B is a diagonal matrix. So of course the determinant would be the product of the numbers on the main diagonal. So 3 times 5 times 2, and that's 30. B inverse. B is diagonal matrix. So B inverse would be just the inverse of the numbers on the main diagonal. So this is 3. We have 3. So the inverse is 1 over 3. And 5. So the inverse is 1 over 5. The reciprocal. Just the reciprocal. And 2, the reciprocal is half. So this is B inverse. When the matrix is diagonal matrix, it's very easy to find the inverse. Also, it's very easy to find power of matrices. B to the power 7, which means B times B times B 7 times. If it is not diagonal, for example, A to the power 7 is not easy to calculate. But since B is diagonal, so B to the power 7 is just 3 to the power 7 and 5 to the power 7 and 2 to the power 7. So that's the answer. The transpose of 2A. So let us first find the matrix 2A. So we need to multiply each number in A by 2. So 4, -6, 10, 0, 2, -6, 0, 0, -8. And then we find the transpose of 2A. Transpose means writing the rows as columns. So 4, -6, 10 is the first row in 2A. It would be the first column in 2A transpose. 0, 2, -6 is the second row. It would be the second column here. And 0, 0, -8 is the third row. You just write it as the third column. This is the transpose. You will notice that the elements on the main diagonal are the same, but the elements not on the main diagonal are interchanged with each other. So -6 with 0 and 10 with 0 and -6 again with 0. This what happens when you evaluate the transpose. Trace of AB. Well, we know how to multiply A, B. We can multiply as usual. But if A is an upper triangular or lower triangular, and B is also upper triangular or diagonal or lower triangular, we know that what are the elements on the main diagonal. Notice that to find the trace, we need the elements on the main diagonal. The other entries are not important because the trace, we just add these numbers. So you can find these three numbers easily because this is upper triangular and this is diagonal by multiplying the numbers on the main diagonal on both matrices. So 2 times 3, so I'll have 6 here, and 1 times 5, and then negative 4 times 2. So 1 times 5 is 5, and negative 4 times 2 is negative 8. And the trace of AB would be 6 plus 5. You just add the numbers on the main diagonal. So 6 plus 5, 11 minus 8. So the answer is 3. That's the trace of AB. Solve the linear system by any method. The general method is the Gaussian elimination or the Gauss and Jordan. I don't know whether this system has one solution or infinitely many solutions or no solution. I can check by calculator. And I guess if you check by calculator, you will find math error or something. So it will not give you a solution. Then we don't know whether it has one solution or, sorry, no solution or infinitely many solutions. So I'll immediately use Gaussian elimination method. First, I write the augmented matrix. So let me write the coefficients from the first equation, and then the coefficients from the second equation, and the coefficients from the last equation. I can put a vertical bar here if you want. So these are the coefficients of x1, and these are the coefficients of x2, and these are the coefficients of x3, and these are the constant numbers written on the right-hand side. And now to use Gaussian elimination, this number, the first number, it is now 2, we should make it 1. And to make 1, to change a number to 1, you have two ways, either to divide the first row by 2, or if you have 1 below, you can interchange the two rows. There is no 1 below, so the easiest way here is to divide row 1 by 2. So I will have 1, 1, 1, 0, and the second row and the third row will not change. Now I have 1 here. I want to make negative 2 and 8 zeros using this 1. This is the leading one in this column, in the first column. So what to do? I multiply row 1 by 2 and add to row 2. Also to make 8 0, I multiply row 1 by 8, negative 8, and add to row 3. So the new matrix would be, the first row is not changing, and this is 0. So if you multiply 0 by any number and add, it will not change the numbers below. Now 2 minus 2, that's 0. 2 plus 5, that's 7. 2 plus 2, that's 4. Negative 8 plus 8, that's 0. Negative 8 plus 1 is negative 7. Negative 8 plus 4 is negative 4. We notice that if we add R2 plus R3, we will get zeros on the last row. And I also can divide R2 by 7 to have 1 here. So adding row 2 plus row 3, 7 minus 7, 0, 4 minus 4, 0, and 1 minus 1, 0, and then I divided by 7. I divided row 2 by 7. This is the final shape in Gauss elimination method. Here, this is the leading one, and below I have zeros. Here in the second column, this is the leading one, and I have 0 here. And this number, I should change it to 1, but I can't because we said to change a number to 1, either you divide by or you interchange with a number below, a 1 below. Nothing is possible here, is possible here. So this is the last form. I can write the equations again. So I have x1 plus x2 plus x3 equals 0, and x2 plus 4 over 7 x3 is 1 over 7, and I have 0 equals to 0. Since there are leading ones here for x1 and x2, x3, there is no leading one. x3 is a free variable. So I will call x3 t, where t is a parameter. And then from the second row here, x2 would be equal to 1 over 7 minus 4 over 7 x3, which is t. And I can find x1 from the first equation. I have x1, x2 is 1 over 7 minus 4 over 7t, and x3 is t. This all equals to 0. So from here, I can find that x1 equals negative 1 over 7, and this negative 4 over 7 plus 7 over 7 is 3 over 7. If you take it to the other side, it's negative 3 over 7t, and t belongs to R. So this is the solution of the system. Find all values of k for which the augmented matrix corresponds to a consistent linear system. Consistent linear system means either it has one solution or infinitely many solutions. If the system has no solution, we call it inconsistent. So this is an augmented matrix. So there is a vertical line here, and I can use Gaussian elimination. This is 1, so let me multiply row 1 by 2 and add to row 2, so I make this number 0. So I'll have 1k and 3, and the second row would be 2 minus 2, that's 0. 2k plus 3, so 2k plus 3, and 6 plus 1, that's 7. And now I need to make this number 2k plus 3, I need to make it 1. Well, I can divide by 2k plus 3, but under the condition that it is not equal to 0. If 2k plus 3 is 0, then I cannot divide by 0. So I have two cases. If 2k plus 3 is 0, this means that 2k equals negative 3, so k is negative 3 over 2. If k is negative 3 over 2, then we will have this matrix 1, negative 3 over 2, and 3, and we will have 0, and here 0 because 2k plus 3 is 0, and here 7. And if you write the equations, the second equation would be 0 equals to 7, and this is not correct, impossible. So here we have no solution. The system is inconsistent. So if k is negative 3 over 2, we will have an inconsistent system. But he is asking for the values of k for which we have a consistent linear system. So what happens the other case? What is the other possibility? Either k is negative 3 over 2 or k is not negative 3 over 2. Well, what would happen in this case? We will have 1 and k, which is a number different than negative 3 over 2, and we will have 0, and we can divide by 2k plus 3 in this case, and having a 1 here, and here we will have 7 over 2k plus 3. And this is a number. This is just a number. So y would be equal to a number. and then x would be equal to a number, and we will have one solution. We will get one solution. Y would be equal to a number and x is number. So we have, for example, 2, 3, 4, 5, one solution. So the system is consistent. So there are no values of k here that makes the system have infinitely many solutions. Only one solution or no solution. Well, so what would be the answer to the question? Find all values of k for which the augmented matrix corresponds to a consistent. One solution means consistent. So if k is not equal to -3/2, we have a consistent linear system. So that's the answer. K shouldn't be -3/2. This is a matrix A. The determinant is given. Find determinant 8A. Using the formula, this I will write it like this, determinant 8A. Then the answer would be 8 to the power 3 because there are 3 rows and 3 columns times the determinant of A. So uh, the determinant of A is -5. So 8 to the power 3, if you want to find the answer, is 512 times -5, the determinant of A. So the answer would be -2560. Determinant of A inverse is 1 over determinant A. So it's 1 over -5. That's the rule. Determinant of this matrix, we'll compare this matrix with A, with the original one, A. So I have A, B, C, D, E, F, G, H, I. All the rows are in position. But here he multiplied by 4. I have 4A, 4B, 4C. So I can, in fact, take this 4 outside as a common factor. I also have minus sign below, so I can take it as a common factor from the third row. So 4 is a common factor from the first row. -1 is a common factor from the third row. And I still have A, B, C. But this is a determinant, okay? So I'm going to use the symbol of the determinant, okay? And I didn't write determinant, I wrote the symbol. I used the symbol. So I have D, E, F, G, H, I. So this is in fact the determinant of A, which is -5. So I have -4 times determinant of A, which is -5 given in the question. So the answer is 20. Use Cramer's rule to solve the linear system. Well, using Cramer's rule, x1 is determinant of A over determinant of A1, and x2 is determinant, it is determinant of A1 over determinant of A, and x2 determinant of A2 over determinant of A. So let us find the determinant of A. Determinant of A is the coefficient matrix. So I write the coefficients 7, -2, 3, and 1. These are the coefficients. These are the coefficients of x1. These are the coefficients of x2. 7, the determinant is 7, minus -2 times 3 is -6, so +6. So the determinant is 13. Now I need to find the determinant of Alhamdulillah, A1. And how to find the determinant of A1? I replace the first column, 7, 3, in A by the constant terms, 3 and 5, 3 and 5. But -2 and 1, keep it as it is. So we change the first column. It's the determinant, so should use the symbol of the determinant. Okay, 3 minus -2 times 5, -10, so +10. So it's 13. So 13 over 13, that's 1. Let us find the determinant of A2. Well, A2, 7, 3 will remain as no change, without change. And -2 and 1, the second column, I'll change it with 3, 5, the constants. So find the determinant. 7 times 5, that's 35, minus 3 times 3, that's 9. So 35 minus 9 is just 26. So you write here 26, 2. So the solution set is 1 and 2. And you can use mode 5, 1 to check your answer that my answer is correct. So you put the coefficient 7, negative 2, 3, and then 3, 1, 5, and it is written here in the required form. So the answer is 1 and 2. So my answer is correct. Consider the vectors v and w. Find the Euclidean distance between v and w. Well, the Euclidean distance, we say dvw equals square root of the difference between them squared. So 4 minus minus 3 squared and plus negative 2 minus 1 squared. Negative 2 minus 1 is negative 3 squared. Negative 2 minus minus 2. So negative 2 plus 2, that's 0 squared. So the answer is 49 plus 9. So 7 squared is 49 plus 9, that's 58. So the distance is square root of 58, the distance between these two vectors. Find the cosine of the angle between the vectors v and w. State whether that angle is acute or obtuse or 90 degrees. The cosine, he's asking about the cosine of the angle, let us call it alpha. By formula, it is v dot w, the inner product, over the norm of v times the norm of w. The inner product, we multiply negative 3 times 4. That's negative 12, plus 1 times negative 2, plus negative 2 times negative 2. This is called the inner product between two vectors. Okay, the norm of v, we square the numbers. Negative 3 squared, that's 9, plus 1 squared. It is similar to the distance, but the distance between the vector and the origin. Also here, norm of w, 4 squared, 16. Negative 2 squared, 4. Negative 2 squared, 4. So the answer is negative 14 plus 4, that's negative 10. And here I have 14. And here I have 16 plus 4, 20 plus 4, 24. So that's the cosine of the angle. It's a negative number. Since cosine of the angle is negative, so we know that the angle must be in the second quadrant. So the angle is obtuse. Alpha is obtuse. If cosine is positive, it would be acute. If the cosine is 0, then the angle would be 90. These are the three cases. Consider these two vectors. Find the vector component of u along A. This is the projection. So we have a vector A and a vector u, and we need to find the projection of u on A. This is called the vector component of u along A. By definition, it is called projection of u along A. We write it like this, and it is u dot A over norm A square times the vector A times the vector A. So u dot A would be the inner product, 2 times 1, 0 times 2, that's at 0, 1 plus 1 times 3. So it's 2 plus 3 over the norm of A. So it is the square root of, but since it's squared, So there is no need of the square root. So it's 1 plus 4 plus 9 times A, where A is 1, 2, 3. That's the vector A. So 2 plus 3 is 5. 1 plus 4, 5 plus 9, that's 14, times 1, 2, 3. So the projection would be 5 over 14 times 1, 5 over 14 times 2, that's, let us say, 10 over 14, or you can say 5 over 7. 5 over 14 times 3, that's 15 over 14. So this is the projection. This is the answer of this part. Now find the vector component of U orthogonal to A. The one orthogonal to A is here, okay? Orthogonal to A. That one by definition is U minus projection of U along A. So U is 2, 0, 1. This is the vector U in the question, minus the projection which we evaluated in part 1. The projection is 5 over 14, 10 over 14, and 15 over 14. So you just subtract 2 minus 5 over 14. The answer is 23 over 14. 0 minus 10 over 14. 1 minus 15 over 14. So it is negative 1 over 14. So this is the answer. Find the distance between the point and the plane. Well, there is a formula to evaluate this distance. If this point has coordinates x, y, z, and the plane is written in the form ax plus by plus cz plus d equals to 0, then the distance is evaluated by, we multiply ax, so it's similar to the inner product, ax plus by, instead of calling this xyz because I have xyz there, so let me just call it x1, x2, x3, okay? So so there is no confusion. So ax1 plus bx2 plus cx3 plus d, the absolute value of this, over the square root of a square plus b square plus c square. That's the formula. So you just apply it. So negative 1 times 2, that's negative 2. Don't forget the absolute value. Negative 1 times 5, that's negative 5. 2 times negative 6, that's negative 12. Plus d. So d has to be on the left-hand side. So you have to bring 4 here. So I'll have negative 4. Okay, because when you bring it to the left-hand side, it would be negative 4. So you take it as it is, over square root of 2 square, that's 4, 5 square, that's 25, negative 6 square, that's 36, and then you find the answer. Now negative 2 minus 5, that's negative 7, minus 12, that's negative 19, minus 4, that's negative 23. Taking the absolute value, I'll have 23 up, and here I have a square root of 29 plus 36, that's 65. So this is the distance between the point and the plane. The area of the parallelogram determined by these two vectors. In R3, we are in R3 in the space, and for the rule says the area of the parallelogram is in fact given by the norm of the cross product of U and V. To find the cross product of U and V, we write them like this: 3, negative 1, 4, 1, 2, minus 5. Well, U cross V is a vector. Cross product is a vector. The answer would be a vector, okay? So the first component to find the first component, you cover the first component here. You cover the first column. So forget about the first column. Forget about this one. And multiply. Negative, find the determinant. -1 times -5, that's 5 minus 8. So 5 minus 8. And the second component, there is a minus sign. Let me put back 3 and 1. Now forget about -1 and 2. Forget about the second one, okay? And find the determinant. 3 times -5, that's -15 minus 4. This is the second component. So let me write -1 and 2 back. And to find the third component, forget about the last column and find the determinant. So 6 minus -1, that's +1. So the cross product will be 5 minus 8, this is -3. -5 minus 4, -19 times negative, this is 19 and 7. So this is the cross product of U and V. Well, the norm would be square root of 9, -3 squared, plus 19 squared, plus 7 squared. And the answer would be under the square root 419. So square root 419 is the area of the parallelogram. So the area of the parallelogram is equal to this. Area is equal to this, okay? Is equal to norm of U cross V. Well, this is the end of this exam. Hopefully you benefit from this video. See you in another one.